First of all, thanks for this opportunity, and hi, my name is Yngwie. I'm a student at the Department of Psychology, and I will be sharing some work done in collaboration with Fabio Trecker of Tryggfondens Børneforskningscenter, Stefan Pfatteicher of the Department of Psychology, and Morten Christensen of LIX. This is not kind of like a research project with results and conclusions, more so as it's a couple of steps we've taken towards building a large-scale database available for researchers. So I can't share results and interesting things like that, but more like promises of perhaps future results. Specifically, we worked on adding Danish to an upcoming database on the semantic priming effect. And so I'll begin by acquainting you, or perhaps reacquainting you, with the semantic priming effect. Then I'll talk a little bit about the database and the potential uses of it. Now, right, semantic priming is typically attributed to this 1971 paper by Meyer and Schwanefeld, who were memory researchers, and their, construal of memory was a bit like this. Now, I'm not asking you to subscribe to this model of memory, but this is to get in the Meyer and Schwanefeld mindset. And as you can see, it's kind of like this network thought with some nodes representing different concepts. You have, for example, a node of representing bird connected to the subordinate concept of robin. And so when you're thinking like this, one of the implications is that, say, a robin flew by as depicted. Then you would get some activation in the network around robin. This might spread to related concepts like bird and canary and animal and so forth, right? Now, Meyer and Schwanefeld had this in their head, or so they thought, and they were examining it using this particular task or this particular paradigm, which has become very prolific in very prolifically used within psycholinguistics. It's known as the lexical decision task. It's quite simple. It works like this. You have two buttons, and then you're shown a string of letters, and that string of letters might be a real word, such as nurse. And if it is, your task is to click on the real word button as fast as you can, or it might be a fake word like a hearse, something that doesn't exist but perhaps could be a word, and if you read that, your task is to click on the non-word button as fast as you can. And if you're a participant in one of these experiments, it might look a little bit like this. You see hearse, that's a non-word, so you click non-word. Then you see doctor, that's a word, so you click word as fast as you can. And then you see nurse, for instance, and then you click word again as fast as you can. Right, this is how it looks for a participant being part of a semantic priming study. Now, perhaps you saw tractor, you realized that was a word, and then you saw nurse, you realized that was a word, and when you were responding to nurse, you took about, say, 600 milliseconds to realize it was a word. Right? Or let's say a lot of participants, on average, took about 600 milliseconds to respond to that. Other participants might have seen a slightly different sequence of words. Perhaps they saw doctor, that's a word, then they saw nurse, that's also a word, but this time it only took them 575 milliseconds to realize that nurse is a real word. Now what you see here is a reduction in reaction time when processing a word that follows a semantically related word, so here doctor and nurse, and that is the semantic priming effect. Now this could arise for many different reasons, could be the network, so on and so forth, but it's an effect, it's quite robust, and it's studied in regard to a lot of different phenomena, mostly semantic memory, semantic dementia, and these kind of fields. So that's semantic priming. Now onto the database. We joined this international collaboration called the Semantic Priming Across Many Languages project. It's run by Aaron Buchanan of the University of Harrisburg in collaboration with the Psychological Science Accelerator, which some of you might know is a platform for building these large-scale collaborations. As the name implies, it's about semantic priming, and it's about many languages. So there is actually previous work on building databases on semantic priming, something called the Semantic Priming Project. However, there are weaknesses in the extant databases. Mostly they're very small. So if you want to analyze a single pair of words, there's really not a lot of observations to do that. And of course it's only in English, as you might expect, the previous research, only in English. So that's kind of the idea behind this project is now we want to do it bigger and with more languages. And in fact, they also ran this project as a registered report with principal acceptance now at Nature Human Behavior. So I don't know, stay tuned. Anyway, it looked a bit like this. First, Aaron Buchanan mined 1,000 word pairs from a corpus of subtitles. Here are some examples: daughter and son, bread and cheese, safe and secure. Then she generated, so these are 2,000 words, then she generated 2,000 fake words, and then they handed all of that onto us. So we did we translated these into, as you can see, data søn, brød, ost, and so on. This was done by 2 native speakers, one to do the translation, one to do the checking. And now we suddenly had 1,000 word pairs. Right. Then we ran an experiment exactly like the one you've just been in. Right? You see the fixation cross, then the response, then another fixation cross and response. But except with 3 trials, it is now 800 trials. So it's a very, very long ordeal with some breaks. We ran this with 800 participants. So we have 800 participants with 800 trials. And this is, of course, like the idea is to just get a lot of data. Yeah, so that's kind of more or less what happened. Now, we're of course only part of a bigger project. Here's a bit of an overview. As you can see here, we are on a 7th place with 800 participants. These are participant counts. As you can see, there are 6 languages now with around 1,000 to 2,000, 3,000 responses. And then there are a handful of up-and-coming ones. There are also more than these, but I cut off the ones that have the most work to do so far. Now, the plan from Aaron is that once these 4 languages, German, Portuguese, Chinese, and French, reach around 800 or so participants, the database is published for everyone. And but it's still going to be running, so you can still add more data onto it. But this is when it will first be published and be available for everyone. And they expect this to be within the year or so. I'm not entirely sure. But yeah, so this was kind of the database. I want to talk a bit about some potential uses. Now, as I said, the data has not been published yet, so it's going to be a bit speculative. But there is, of course, this previous project, the Semantic Priming project, which we can rely on. And I'll tell you a little bit about what people have done with that and what I hope people can maybe do with this new thing. Yes,
Quick question, was it done online?
Everything was done online, yes. Right. And in fact, it was done using there's only one online central platform that runs all of the experiments across all countries. And then it depending on which language you are, it's just samples from a different set of stimuli. So everyone got exactly the same treatment of it, but it was online, yeah. Right. Now, one way that a database like this could be used is, I guess, a bit obvious. You could use it if you want to run a semantic priming study. So instead of generating your own stimuli, here you have some pre-generated stimuli. And they're not just pre-generated, you also have some information about them. For example, you know what the average response time is. So you can norm your stimuli with regard to the response time and other things, such as how similar they are. Now, it's in the works, so there's at least a plan to include norms of all of the stimuli, in the sense that you have participants go through and they read each word, and then they say, how concrete is this? At what age did you learn this, and so on and so forth, with all these other, like I guess, nuisance factors or typical factors that are studied within this field. Finally, of course, if you use pre-generated stimuli where you know the response times, you also have a good sense of the effect size. So this is a big help to experimentalists, right? That you can kind of power your study. You know more or less how many participants you need. But if you look at how people use the semantic priming project, actually a way more prolific use was secondary data analysis. It was just to test and validate models. And I'll give you 2 examples. This is kind of like the typical way to use a database like this. So these researchers compared 2 different models of semantic memory. And one model stated that words that occur together typically are related. So they could build this model, they could have it read a bunch of text and remember how many times did this word occur with this word and so on. And then based on that, they could predict how related are 2 word pairs. Is a word pair. So of course they could use this on the database, kind of make predictions. How related is brød and ost, or bread and cheese, right? And so on and so forth. They had a second model as well, which was kind of similar in spirit, but instead it tried to predict an upcoming word in a sentence based on the words it just read. And so this is kind of another way of thinking about it. But this model, crucially, was also able to predict how related do we think these 2 words are. But how do you pick between these models? Well, if you have a database like this, you can just see which one of them best reproduces the data, which one makes the best predictions in terms of the reaction times and all these stimuli. And this is like a typical way of using it, but I also want to share this one, which is a paper I really enjoy. They did something quite similar, still thinking about like the context of words, but they instead of looking at like which words co-occur, they look at which sentence structures, so what kind of syntax does a word typically occur in, does it occur as a subject of a sentence and so on and so forth. And they find that words that tend to occur in similar structures also tend to elicit as what's it called, a semantic priming effect. So you can actually, if you're what's called creative enough, you can also use this database going beyond just like the semantic memory and like within the semantic domain. But anyway, now for the final, I think the most speculative part, but also perhaps the most exciting part, is of course the novel part of this project is Danish, and it's all the other languages, and it's also the thing that we don't know anything about yet because it's not published. But I guess we all have like a growing recognition that, you know, just studying English is a bit unfortunate. You know, there are differences between languages and differences between the users of different languages. And in particular, there's some work here from the IMC by Didriksen et al. On how Danish might be a very, very interesting and very particular language. So in this paper, they found that Danes, in comparison with Norwegians, actually tend to elicit more semantic priming or semantic alignment during conversation. And so this is in terms of interaction and conversation, one of the ideas is that semantic priming is a kind of device that helps us speak fluently, have efficient communication, develop a common understanding and so on. And it turns out that perhaps Danes are a bit special in this regard, at least when compared to Norwegians. We tend to show more of this. And I guess it's kind of in this direction, I hope, that we might see some work coming from this database. But yeah, unfortunately I can't share anything as of yet. But right, some acknowledgements. Fabio, Morten and Stefan, and we also had 3 brilliant RAs with us, Anna Stykler, Dean Eriksen and Anna Boysen. And of course thank you to the Psych Science Accelerator and Interactive Mind Center for making this all possible. That's it.